in the system, thermal loads. So these are our i7 nodes, the black ones, and we chose two configurations. So I have to start from the air perhaps. The air enters here and goes down through the system and exits the node on the other side. So we have two configurations, one with the nodes close to the inlet and one with the hot nodes close to the exit. And on this side, these ones here are AMD, low power AMD and nodes. Yeah. And these here are i7s again, high power. We've got one with two high power nodes behind each other. So this should get us the hottest part, and here two opposite. And what we demonstrated last time was close to what you see now. We simulated the airflow through the system, and this is represented as streamlines going through the system from top to bottom, as we see it here. But today we can show more. We can also show the thermal behavior of the system. If I look at this again, you now see color on a cutting surface through the system representing the temperatures. So you clearly see that these nodes here are hotter. They create more heat, so the air warms up, and this also reflects here at these outlets. While you see a good difference between the temperature on this node here, on this exit, this is even higher than the one here, right? And from a simple point of view, these two provide the exact same amount of power, so should result in the same temperature. But in the physical test bed, we are measuring the same temperature difference between these outlets. So we actually did a verification of our simulation. We compared it to actual measurements in the running system, and the temperature difference is 1 degree. And that's also what we measure on the sensors, right? Similar, if we look over to these, let's look at it from the other side. If you look at the ones far to the right, a little hard to see, but here we obviously have the highest temperature with the two hot nodes behind each other. Okay, I think this is what I can show you on this system. Well, another aspect I have to tell you, what we showed in the first review was a handmade simulation. We set this up by hand and did a simulation and presented the results. This is an automatic simulation coming out of our SVD toolkit. So the geometry has been created in our system with the depth configurator that will be presented later. The values, the boundary conditions, the temperature of the inlets, and the power of the system is coming out of the simulation, out of the workload simulation. It could also come from the measurements, but we wanted to compare the simulation with the actual experiment, and the output is then also presented in our SVD toolkit and can be compared online, and you'll see that later throughout the